Okay, this is a short lecture that's going to compare the two types of magma. We have basaltic magma, which can also be called mafic. Ma for mafic stands for magnesium, F in mafic stands for iron. So mafic rocks are going to be very dark and have a high density. If you remember back from our plate tectonic unit, we know that oceanic crusts have a high density. That is because they're made of basaltic magma. So basaltic magma is going to form the oceanic crust. Now the iron and magnesia in mafic magma is going to melt at a much higher temperature. Since it's at a much higher temperature, it's tended going to have a lot more fluidity, very low viscosity. That's going to cause the volcano to become non-explosive. So they're not going to erupt in these big massive explosions like Mount St. Helens. When that lava starts to solidify, it's going to produce what is called pohoihoi lava. It is a Hawaiian term, and it is known for having a very ropey texture, nice and smooth. Okay, so granitic rock can also be called felsic. It has lots of silicon minerals, silicon and oxygen type minerals. It's going to form the continental crust. They have a much lower density, which is why the continental crust floats higher in the mantle. The silicon and oxygen type minerals melt at a much lower temperature than the iron and magnesium, so that lava is going to be really thick as it's coming out. Because it's thick, it's going to get stuck in the crust, and that's going to allow pressure to build up, and that's going to cause a bigger explosion. The type of lava that granitic magma will form is called A'a lava. A'a lava is very jagged. Because of its thick nature, it's going to crumble and sort of fall down the slopes and tumble, and it's going to mix some air into it, so you'll often get lots of air bubbles within the A'a lava. They're very jagged, so it would hurt if you walked on them, hence the term A'a. You would tend to go, ah, my foot hurts. And that wraps up our quick unit on types of magma.